Today I'm going to talk about introduction of trusses, different types of trusses, the stability criteria required in the trusses. What are trusses? What are the different examples of trusses? We will first discuss about that, and then we will see how to solve a truss question. This is the simplest form of a truss, a triangular truss. This is a rigid, non-deformable truss. This is a second form of truss which is not stable. We will discuss what is the stability criteria of a truss. What are the examples of trusses? And trusses are basically the building structures which you see on a regular basis. For example, the bridge design, that is a form of truss. The electrical transmission lines, even that is a kind of truss. So these are the regular, very common examples of trusses. Now, what is the stability criteria for a truss? M equal to 2j minus R. Now, what are these alphabets given over here? M is the number of members, J is the number of joints, and R is the number of reactions. Now, for example, if I take any simple truss, it should satisfy this condition of M equal to 2j minus R. Now, I'll give you one example of a truss. The triangular truss that we had seen initially. Now, this truss is having three members. 1, 2, and 3. J, number of joints. We have 3 joints. Reactions. For the hinge support, we have 2 reactions along the x direction and along the y direction. For the roller support, we have only one reaction that is perpendicular to the surface, that is in the y direction. So the total number of reactions that I have is 3. Now I'll put up these values in the equation. This shows that it is a stable truss because my left hand side and right hand side are equal. This is the second example that I can show for a truss. Now we will see the stability criteria for the truss. Again, we will define the members, joints, and the reactions. We have 4 members, we have 4 joints, and same as in the previous example, we have 3 reactions. We can see that my left hand side and right hand side both are not same. That means this is not a stable truss. On the left hand side, I can see the number of members as 4, while on the right hand side, I can see the number as 5. Since the number of members is 4, it means that one member is less in this case. So I can say that this is a deficient truss. Now, suppose it happens that if I want to add one member to this truss, and if I add that member, there is a possibility that it will get it will become a stable truss. Now, in this example, you can see that I have made the square truss, but with one more member in between. So my number of members becomes 5. I have the same number of joints, that is 4, and the number of reactions is same, 3. Now this becomes a stable truss because my left hand side and right hand side are same. Suppose in this case again, if I happen to add one more member, so what happens in that case? Now you can see that I have the square truss with 2 extra members in between. So the number of members is 6, number of joints that I'm having is still the same, that is 4, and number of reactions is again the same, that is 3. Now you can see that my left hand side and right hand side both are not same. My left hand side is a higher number as compared to the right hand side. That means I have one extra member in this truss, and that type of a truss is known as redundant truss.